If sine theta is negative and cosine theta is positive, what quadrant must theta be in? Recall the acronym ASTC. All students take calculus. A represents all things are positive. S represents that sine is positive in this quadrant. T represents that tan is positive in this quadrant. And for C, cosine is positive in this quadrant here. Now we're given some clues. Sine of the angle is negative. So because sine is positive here and all things are positive here, the clues indicate that sine might be here, it might be here. We have another clue. Cosine theta is positive as well. So cosine positive is certainly true over here. Now cosine is not positive here because this is tan land. Only tan is positive here. So the body of evidence indicates that this quadrant here is where theta lies in. Let's solve the following trig equations within this domain, 0 to 360 degrees, one full turn. So we have a classic type of trig problem. Trig, sine, cos, or tan of some unknown angle equals some special value. How do we attack this kind of problem? We approach this problem with a karate chop. Hiya. ASTC, all students take calculus, or all things are positive, sine is positive, tan is positive, cosine is positive. And we're talking about sine. Sine theta is positive 1/2. Where? In this quadrant and this quadrant. So Haya, ASTC, check. In which quadrants do we have a positive value? Now what is this value? Particularly we have the value 1/2 or 0.5. Now what do we know about the reference angle for 0.5? Sine of what is 1/2? One way of doing this is to memorize the special triangle. 1, 2, root 3. This is 30. This is 60 degrees. So indeed, sine 30 is opposite over hypotenuse, which is 1/2. So the reference angle is 30 degrees. So we write down 30 as the reference here. And remember that the reference angle is the angle formed between the x-axis and the terminal arm. Okay, so finally we get the answers. Theta. You start on the right and you run the track counterclockwise, and every time you hit this terminal arm, we found the solution. So theta 1 equals 30 degrees. That's this arm here. Now let's beat our personal best and run the track further, making it all the way here. This entire amount is 180, minus 30 is 150. So theta 2, the second possible answer, is 150 degrees. So we have two solutions, 30 and 150. So let's continue solving for theta. Trig of unknown angle equals some special value. So we attack this question with a nice karate chop. Haya, ASTC. Focus on the sign being negative. Where is sine negative? Sine is negative in this quadrant and this quadrant, in quadrants 3 and 4. Now focus on the value portion. Sine of what is 1 over root 2? It's good to memorize these, but we have 1 root 2 as a very special triangle. And sine 45 is opposite over hypotenuse, which is 1 over root 2. So the reference angle is 45 degrees, which is the angle between the x-axis and the terminal arm. The reference angle must always be positive between 0 and 90. And we now run the track. 180 plus 45 is theta 1, which is 225 degrees. Now let's set a personal best. We go all the way around, which is 270 plus 45, or you could think of this as 360 minus 45. Theta 2 is equals to 315 degrees. So we're now getting the hang of this. We don't have to have theta, we can have any angle. In this case, we have angle A. So we solve A, the possible values within one full turn. We'll call this A. Haya, ASTC. We know that sine is positive here and here. And sine of what is root 2 over 2? That's 45 degrees because 1 over 2 rationalized is root 2 over 2. So we draw an arm here and here, and the reference angle is 45. So A1 subscript 1 equals, running the track this way, 45 degrees. And A2 is 90 plus 45, or 180 minus 45, which is 135 degrees. We solve the possible values of A.